Today at Kicked Up Chemistry, we're going to take a tour of the periodic table of the elements, which was first created by the modern periodic table by Dmitry Mendeleev, a Russian chemist, and it's kind of evolved over the time, and it's a very, very useful tool, one of the chemists' most useful tool that they have to use in chemistry and chemical reactions. Alright, so today we're going to look at the periodic table of the elements. Now you can go online and find a blank periodic table of the elements and fill it out as you go along as well. And I've already kind of darkened in, most of them already have this line kind of darkened in here. This separates the metals from the nonmetals on the periodic table. So to the left of that line are the metals, to the right are the nonmetals. Now all of the names and the symbols of the elements are governed by a group called IUPAC, which is the International Union of Pure and Applied Chemistry. So on the IUPAC periodic table, the columns, also known as families or groups because they share similar chemical and physical characteristics, they are numbered 1 through 18. So we have group 1, group 2, 3, 4, all the way over to group 18. Now on some other periodic tables, you'll notice a different naming scheme. So for instance, in addition to having the 1 through 18, it also has 1A, 2A, then down here 3A, and then there's another naming scheme where it has 1A, 2A, and most of them pretty much are the same until you get into this group right here. So this is group 8A, 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 group 8, group 8, group 8. Now there is a reason for that, but we're not going to worry about it. We're just going to number our table 1 through 18 left to right. Now going across are the periods, and there are 7 periods. 1, 2, 3, 4, 5, 6, 7. So there are these 7 periods. Now some of these families or groups have special names. So we're going to go ahead and we're going to fill in some of these. So first of all, we have hydrogen. Hydrogen is kind of its own little element there, and I went ahead and put an ion on their ionic charge. On some periodic tables, they actually have hydrogen over here as well. Sometimes there's an extra little spot, a little gap right there, because hydrogen is not really an alkali metal, and that's what group 1 is, the alkali metals. Now group 2 right next to it, which would include beryllium, magnesium, calcium, strontium, barium, and radium, are called the alkaline earth metals. And I'll just write metals here because ran out of room. And then we're going to jump over to the other side of the periodic table, over here to group 18. Group 18 includes helium, neon, argon, krypton, xenon, and radon, and those are the noble gases, also called the inert gases. So we have the noble gases. Right next to that then are the halogens. So we have fluorine, chlorine, bromine, iodine, and then astatine. Astatine is a radioactive decay product, and we're not really going to worry about astatine too much. Now, group 16, which is sometimes called the oxygen group, has a special name, and they are called the chalcogens, spelled C-H-A-L-C-O-G-E-N, chalcogen. Now, next to the chalcogens, nitrogen, phosphorus, and arsenic, because they only go down to the stair-step line, really, are the pnictogens. So my line might go a little bit further than that. So the pnictogens, we have nitrogen and phosphorus, so they got the P and the N in there. Always reminds me of, hey, how come you can't hear a pterodactyl go to the bathroom? Because the P is silent. Ha 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 ha. Okay, so those are the pnictogens. Now, from group 3 through group 12 are called the transition metals. Now you may notice on the periodic table that right here is element 56, but then next to it is element 72. Actually, on different periodic tables put them a little bit differently. So we can see on this periodic table it has a gap there. This one it has an extra dark line. So on this one they actually put lanthanum here and actinium here, even though on most periodic tables they come down here and they start them down there. These are called the lanthanide series and the actinide series. So these are the lanthanides. These are the actinides. Now collectively these are known as the inner transition elements. Because they would be inside the transition metals, or inner transition metals would be another term for that. Now, if you put those in the body of the periodic table, and subperiodic tables are, then it gets really, really long. Doesn't fit in there quite as well, but hey, it is what it is. All right. So once we go through those, then we have a couple of other things. If something is right between a metal and a non-metal, then it is called a metalloid. And so our metalloids would be boron, silicon, germanium. Right here would be arsenic, antimony, tellurium, and polonium. So those are the metalloids. They have characteristics of being both a metal and a non-metal. Now, another thing that we have are elements that are always paired up with another element of the same, or another atom of the same element. So for instance, oxygen is always O2. So it always pairs up with another oxygen. You're not going to breathe in a single oxygen atom. You always breathe in a molecule of oxygen. Same thing with hydrogen. Hydrogen is H2. And these elements in nature always occur that way as a diatomic. There are 7 of them. Now, there are all kinds of mnemonic devices out there for remembering them. I know Hofbrinkel is one of them. It's the first letter of each of the elements. Brofinkel. Here's the one that I came up with that I like. It starts at element number 7, which is right here, which is nitrogen. And we have nitrogen, oxygen, fluorine, chlorine, bromine, iodine, and then hydrogen over here is the 7th one. Well, it starts at number 7 and it forms a number 7. And there are 7 of them. So 7, 7, 7. It's a good way, I think, to remember which of the elements are the diatomics. Nitrogen, oxygen, fluorine, chlorine, bromine, iodine. So there's 6. And then hydrogen is the 7th one. So they always appear as a diatomic. Now, in addition to this, we can go ahead and put some charges on our periodic table because certain elements always will gain or lose the same number of electrons. Noble gases have the perfect number of electrons, and they're not going to gain electrons, they're not going to lose electrons. But the halogens all need to gain 1 electron to be like a noble gas. So if you think of the periodic table as kind of like a game board, the goal is to get over here to be where the noble gases are. So all of these have to move over 1 place. Well, that means that they have to gain 1 electron. So all of these have a 1 minus charge. They're going to gain 1 electron. Here, these have to move over 2 places. So these are all a 2 negative charge. And then the nitrogen, phosphorus, and arsenic are going to form a 3 minus charge. So those are the ones that always form the same negative charges. Over on the other side of the periodic table, it's going to be a lot easier for, say, lithium to lose 1 electron to become like helium than to gain 7 electrons to become like neon. And so over here, all of these are going to lose 1 electron. Since electrons are negatively charged, if you take 1 away, you have 1 more proton than electron, and it's a positive charge. The alkaline earth metals are only 2 positive charge. Now, the transition metals and the intertransition metals, by the way, sometimes these lanthanide series and a few other elements up there are also called the rare earths. And it's not that they're that rare. The reason that they are rare earths is because these all have basically the same number of outer electrons, and they're very difficult to separate from each other. So in here, strange things can happen inside of those electron shells, and it can lose various different electrons. But there are a couple of elements that always form the same charge. Aluminum, right here, is always a 3 positive charge. Zinc is always a 2 positive charge. I zinc it is. And then silver is always a 1 positive charge. And then cadmium, being right underneath zinc, is also a 2 positive charge. Now, normally when we would do this in class, we go through, we would take a little more time, fill out the entire periodic table. And as we go along and do it, then we color code it. And so here is my color-coded periodic table. So if you want to get your own colored pencils out and color code your periodic table, that would just makes it a little more fun and interesting and easier to find in your notebook when you're trying to find it. Thanks for watching.